Hey guys. In this video, we're going to be taking a look at continuously compounded interest. So this formula here, you are going to want to write down in your notes and keep close by you. So A equals PE to the RT power. So sometime last week, we took a look at if you compound monthly, compound daily, you put interest in an account, it depreciates. So we know how to do those formulas. Very similar concept today, except for there's another formula, and the key word to this is continuously. So that is the key word that will let you know when to use this formula as opposed to the other formulas. So if you're reading it and it says something is compounded continuously, then this is a formula that you need to use. So let me go through and explain this formula to you, and then we have a problem down here that we're going to go through and work out. So A is going to be our answer. It's going to be our final amount. We put something in the account. It grows continuously. How much do we have back out? So that's going to be our answer. P is your principal, which is what you're starting with. It's your initial amount. E is E, so that's an irrational number that we know of now. And then R is your interest rate as a decimal. So it still must be as a decimal as it was before. So annual interest rate as a decimal. And then T is your time period in years. So you know to use this formula if it says compounded continuously. So let's go through and work out this problem. Suppose you deposit $700 into an account paying 3% annual interest compounded continuously. Part A, what's the balance after 8 years? Part B, how long will it take for the balance in your account to reach at least $1,200? And C, how much would have to be deposited in order to reach a balance of $1,500 after 12 years? So we're going to go through and we're going to solve these equations. So let me see if I can put the problem here all in the same space, and then we can work them out. So part A. All right, there we go. So part A. What is the balance after 8 years? So let's write our formula down. So our formula, A equals PE to the RT. P is what we started with, our initial amount, which is $700. E is E. R is our rate as a decimal. So in the problem up here, it says 3%. I need to change that to just a decimal. So it would be this. And my time period is, they want to know the balance after 8 years. So my time is 8 years. So this one is very straightforward. So that is our setup for this problem here. We're going to go through and type this into Desmos and see what we get. So I'm going to type in 700 E, and my rate is 0.03, and after 8 years. So $889.87. $889.87. And voila. So we started with $700 in the account, and it compounds continuously, meaning over and over and over again. This is how much that we're going to get. All right, part B. Part B says, how long will it take for the balance in your account to reach at least $1,200? So again, I always like to start by writing down your formula so that you can see first what formula you're working with. So make sure you have that written down, and then you can make sure you put the numbers in the correct spot. So how long will it take for the balance in your account to reach at least $1,200? This is our outcome. This is going to actually be our A. This is what we're working with. So $1,200 goes in for A. Our initial amount, we're still starting with $700. E is still E. Our interest rate is still 3% as a decimal. But this time, since it wants to know how long is going to be our time period. So that is going to be T. So that's what we're looking for. So this one's going to be a little bit more involved than the other ones that we did, because we're going to have to solve this equation for T. So step one, 1,200 is equal to 700 E to this power there. So we can divide both sides by 700. So step one, divide both sides by 700. I did have mine as a decimal, but you are more than welcome to keep it as a fraction. So that would just be 12 over 7. So it's nothing wrong with keeping this as 12 over 7. For some reason, when I was working out earlier, I just put it in decimal form. But this is the same as 12 over 7 in fraction form. Now, this is actually what we learned in the previous video. So I have an E here. So I need to take the natural log of both sides. So I'm going to take the natural log of this side. And I'm going to take the natural log of this side. So this is in the previous video that you watched before you got here. Natural log and E cancel out. They make the number 1. So that cancels. So I have the natural log of this is equal to this. And we got one more step. We're trying to get t by itself. So the opposite of multiplying by 0.03 is to divide. So our exact answer is this divided by this equals our time. And our time is going to be in years. So the natural log of 1.714 divided by 300. And I'm going to type this in decimal so we can get an approximation for our time period. So the natural log of this divided by this. So it gives me 17.96, but since I'm working with years, I'm going to round. I'm going to say about 18 years. So this is going to be about 18 years. So the first one gave us everything on the right-hand side of my equation, so I could just plug and chug there. This one gave me the amount that we were looking for, so we had to do a little bit more work. So if you see E, you take the natural log of both sides. If you start with a problem that has natural log, you're going to exponentiate both sides. And I believe that there was one more part to our question that we were working on. So part A said what's the balance after 8 years? So we took care of that. Part B says how long will it take for the balance in your account to reach at least $1,200? And the last thing we need to take a look at is part C. Part C says how much would have to be deposited in order to reach a balance of $1,500 after 12 years? So let's start by writing our formula down. You know to use this formula if it says compounded continuously, which it does up here at the very top of my problem. That's how you know to use Pert. So I want to have out 1,500 after 12 years. So that's going to be that. I don't know how much I need to deposit. That's what we're looking for. So that's going to be P. E is E. My rate is still the same. And my time period is 12. So this is a straightforward problem too. This is P times all of this. So in Desmos, we can type in 1,500 divided by E, divided by all of this, and that'll give us P. So in Desmos, I can type in 1,500 divided by E to the following number. So I'm going to type that into Desmos. 1,500 divided by E. And it's 0.0, 12 years. And I got $1,046.51. So $1,046.51 as our answer. So notice with this one particular formula, all the different things that we can do. So let me zoom out so we can look at it all together. So notice what we can do with this one formula. So we were using Pert. So A equals P e to the RT power. You know to use that if it says compounded continuously. Sometimes like part A and part C is very straightforward. You just plug and chug. Part B required us to do a little bit more work because we had to take the natural log of both sides. But this is Pert.